Welcome to AP Chemistry. I'm your tutor Venkata, and today I'll be covering AP Chemistry 1.1, which is known as the mole concept, although there are more concepts that you'll need to learn about than the mole. Alright, so let's get started. The first thing that we need to talk about when we're dealing with chemistry in general is the mole. And the mole is a very simple concept that tends to be overinflated. So, before we talk about a mole, let's talk about a few other things. Do you know what a dozen is? You probably do. For example, if I told you to get me a dozen eggs, then you would get me 12 eggs. And similarly, if I asked you to bring me a baker's dozen of cupcakes, for example, you would bring me 13 cupcakes. And if I asked you to bring me a gross, for example, of paper clips, you would bring me 144 paper clips. A mole is no different than these numbers. What it just symbolizes is a specific number of things. And this number, it's known as Na, is Avogadro's number. Avogadro's number. Alright? So Avogadro was a chemist, and I'll be explaining more about him when we come to Avogadro's law and future laws in chemistry. But all you need to know is that a mole signifies Avogadro's number of things. And what is this number, you might ask? It's 6.022 times 10 to the power of 23. And it's a very big number, obviously, because of that 10 to the power of 23 right there. Has 23 zeros off to the right. Alright? So this is what a mole is. So for our first practice problem, let me give you this example. If I have a mole of bikes, how many bikes do I have? A mole of bikes. How many bikes do I have? Alright, well, you might say, I have Avogadro's number of bikes. And in a mathematician's terms, it would be 6.022 times 10 to the power of 23 bikes. And this was very straightforward, right? A pretty boring example. Now, to lead into the next concept, let's consider a different problem. If I have a mole of bikes, how many wheels do I have? Wheels. What is the number of wheels that I have? Well, you can do this logically. For example, let's draw a bike for ourselves over here. If I draw myself a bike, and this is a very horrible bike, forgive me if you're a biker. This is a bike, right? It has precisely 2 wheels, which is a very surprising fact. It has 2 wheels, and a mole of bikes, each bike would have 2 wheels. So a mole of bikes would have 2 moles of wheels. It would have 2 moles of wheels. Pretty simple. But there is an algebraic way to do this, or actually a unit-based way to do this, and it is known as dimensional analysis. Sorry, my writing speed is a little slow today, but it is known as dimensional analysis. And depending on your teacher, it might also be known as the factor label method. But don't be confused, they both mean the same exact thing. Alright? So dimensional analysis, what exactly is it? It basically involves taking a unit and then multiplying it by a conversion factor. And this conversion factor is always a fraction. So in this fraction, you have desired units in the numerator, and then you have your unwanted units in the numerator. In the denominator, So let me explain what that means. And then desired. So let's consider an example, this example, about the wheels in a mole of bikes. Alright? So we have we have 1 mole. And remember, I'm writing out the unit after each number for clarity. And because we need to cancel out the units in dimensional analysis, we have a mole of bikes. Alright? Now, what is our conversion factor? Well, we want to get rid of the unit bikes, and we want to replace it with wheels. So we need a conversion factor that explains how to get from bikes to wheels. Or logically, we could think about it and say that there are 2 wheels per bike, right? So we can cancel out bike and bike here, and then this leaves us with 1 times 2 mole of wheels, alright? And this gives us precisely 2 moles of wheels. And that's the answer that we got up here as well, logically. So dimensional analysis basically works by canceling out the unit that you don't want by putting it in the denominator. All right, make sure to talk to me in the comments if you're still confused. And I'll give you another example over here, just for your clarification purposes. Let's suppose that you have 3 feet. 3 feet, and you want to convert this to yards. 2 yards, all right? Well, the conversion factor that you need here is that there are 3 feet per yard, or you could write it as 1 yard per 3 feet. All right, and we'll figure out which one of these is more useful to us in solving this exact problem. All right, so we want to convert 3 feet to yards. How do we do this? Dimensional analysis. Obviously, you can do this mentally as well, but this is an example to show you how dimensional analysis works, because you're going to need it in much more complicated examples later. All right, so converting 3 feet to yards. Let's start with our 3 feet, and then we need to multiply it by our conversion factor, which is 1 yard per 3 feet, and then we can cancel out feet and feet. Do you see that? We have feet over here and then feet in the denominator. So those cancel out, and that leaves us with 1 times 3 divided by 3 yards. All right, and that should actually be yards. And that gives us exactly 1 yard. That was not that difficult of a problem, right? If you're still confused, make sure to let me know in the comments, and I'll give you more practice problems and guided solutions. All right? So that was a pretty simple example. Now, how do we use dimensional analysis in chemistry? Which is obviously why you came here, right? You want to learn about chemistry. So let's consider a classic problem in chemistry, all right? This problem supposes that we have 1 mole of atoms, all right? Atoms. And I'll specify, for our problem's purposes, I'll specify that we have 1 mole of atoms from the element lithium. Lithium, it's the 3rd element in the periodic table, element number 3. Right? Let's suppose we have a mole of atoms from lithium. How many grams of lithium would we have? How many grams of lithium would we have? Well, pause this video and try to figure it out on your own, and if you can't, come back. All right? So this actually requires something known as a molar mass. A molar mass. And this is going to be an important conversion factor in our dimensional analysis work here. So look at the square that you have for lithium on your periodic table. You have lithium, you have its elemental symbol, and then you have its atomic number, 3, and then you also have a number down here, 6.94, or if your periodic table is a little more detailed, it should be something like 6.941. All right, so this is going to be your square on the periodic table for lithium. It's divided into 3 parts that I just talked about, right? That's your atomic number, that's your atomic symbol, and then what is that? Well, that is your molar mass. And a molar mass tells you how many grams of a substance you're going to have if you have 1 mole of that substance. So let me give you an example that clarifies what I mean, and let's do it with the lithium, sorry. So if I have 6.022 times 10 to the power 23 atoms of lithium, then I have 1 mole of lithium. So this is what I mean by saying I have 1 mole of lithium. I'm clarifying that I have 6.022 times 10 to the power of 23 atoms of lithium. All right, so I can write that as 1 mole lithium. And now I want to convert this to grams of lithium. So here's a very important note here. This number over here is its molar mass. The 3rd number over here, the 3rd part over here, 6.941, is the molar mass of lithium. It tells us how many grams we're going to have in 1 mole. So its units are going to be grams per mole, grams over mole. These are going to be the units of molar mass. They tell us how many grams you're going to have per mole. All right? And so let's write that out. We're going to say we have 6.941 grams of lithium per mole of lithium. All right? Grams per mole. Those are our units that we just discussed over here, and that's the value. All right? Hopefully that's starting to make sense for you. All right? So we cancel out moles lithium here and moles lithium over here, and then we're left with 1 times 6.941 grams of lithium. That's just 6.941 grams of lithium. So in 1 mole of lithium atoms, you're going to have exactly 6.941 and I'll clarify that as a 4, 6.941 grams of lithium. Alright, so this was a brief introduction to AP chemistry, and hopefully you're starting to understand how moles, dimensional analysis, and the concept of a molar mass ties together. Alright, I'll give you one example before I end this video, and it's going to be something using the reciprocal molar mass. Alright, so remember, this is your molar mass, grams per mole. The reciprocal of this is going to be moles per gram, right? So, for example, let's come up with a fictional element A. Element A is our fictional element, alright? And let's say that it has a molar mass of 3 grams per mole, alright? 3 grams per mole. Now, let's say that we have 30 grams of element A. How do we figure out the number of moles of element A that we have? How many moles of element A do we have? I encourage you to pause and try to figure out this on your own. Figure this out on your own, sorry. Well, let's go ahead and try to solve it. So, we have 30 grams of element A, and then we multiply it by our conversion factor. Remember, we want to put the units, we want to cancel in the denominator. So we want to cancel grams. We want to cancel this unit grams here. This is just the unit for our molar mass. If you look at it, grams is not in its denominator, so we can't use its molar mass for this. We have to use the reciprocal molar mass, because that has grams in the denominator, alright? So we have to say, instead of 3 grams per mole, which is its molar mass, we have to say 1 mole per 3 grams, alright? And then 3 grams here and grams here cancel, and then that leaves us with 30 over 3 mole element A. And then that just tells us that we have 10 moles of element A. Alright, so that is the solution to this problem. Alright, hopefully it made sense to you. If it didn't, talk to me in the comments. Alright, I'll see you later. Bye.